Despite accounting up 85% of the universe's total mass, dark matter has eluded direct observation. Even after decades of increasingly sensitive astrophysical, cosmological, collider, and direct detection efforts, the particle nature of dark matter is still a mystery. Using the Earth's atmosphere as a massive detector for dark matter particles that are shooting through the air like meteors, a recent study suggests a novel technique to search for it. The cosmos is supposed to be filled with dark matter, which is engulfing us all at this very moment. Why then can't we locate it? Because it is invisible, it seldom ever interacts with ordinary stuff and neither emits nor absorbs nor reflects light. Although it may seem like an overly simple explanation, researchers are fairly certain that dark matter exists. Dark matter does appear to be there, even though it has never been physically verified, because it has a gravitational effect on stars, galaxies, and clusters, whose motions and evolution would not be fully explicable without it. It is hardly surprising that dark matter is the focus of so many studies, given that its discovery would be one of the most significant scientific discoveries of all time. One issue is that there is a large range of probable characteristics for dark matter, including various masses, energy, and interactions. As a result, physicists search a variety of experiments that look for signals depending on characteristics that dark matter may or may not possess. The new study adopts a novel methodology. According to the researchers, if dark matter particles have significant masses, they may occasionally enter the atmosphere of Earth like meteorites and maybe leave behind traces that can be found. The radiation tails that meteors leave behind as they race through the sky create free electrons. The electromagnetic waves transmitted by radar devices are reflected by these ionization deposits, enabling the detection of meteors moving through the atmosphere. According to the researchers, signals from dark matter particles would be comparable yet different. The researchers described what these dark matter meteors would resemble and recommended that a detailed examination of these radar signals could determine whether or not they are all meteors or whether some of them are dark matter particles that are disguising themselves as meteors. This effectively transforms the atmosphere of the entire planet into a massive dark matter detector. The new method is unique in that it would look for a particular kind of dark matter that is frequently disregarded. Dark matter particles can be extremely light and present everywhere, or they might be massive and quite uncommon. The majority of experiments look for the former, typically in big, noise-free facilities deep down. However, if the particles have heavier weights, they might not reach those detectors, which could account for the decades' worth of negative data. By extending the search, the new method may also be used to cross-check any potential detections discovered in prior studies. Of all, it is still only an idea right now, albeit an interesting one.